Hey everyone, today we're going to discuss more about functions. We are going to classify functions whether they are one-to-one or onto. Now, a one-to-one function or an injective function is a function in which for each value of y in the range of f, there is just one value x in the domain of f such that y is equal to f of x. In other words, f is one-to-one if f of x sub 1 is equal to f of x sub 2 implies x sub 1 equals x sub 2. Now, we can say that a function is one-to-one if every value of x corresponds to y's and vice versa. One value of y corresponds to exactly one value of x only. In our example here, let's look at this graph here. We know that this graph is a one-to-one function because one element of x corresponds to one element of y. Example, 1 corresponds to 1. And one value of y corresponds to one value of x. 1 goes to 1. Negative 1 goes to negative 1. In this graph here, this is not an example of a one-to-one function because, if we can see here, 1 corresponds to 4. However, negative 1 also corresponds to 4. Which means that there's a value of y, which is 4, which corresponds to two values of x's, which doesn't make it one-to-one. As a guideline, we know that a function is one-to-one if it passes both the vertical line test and the horizontal line test. We can also do some computations if we don't have the graph, which will be discussed later on. Now, the second classification of a function is onto. A function is onto or surjective if every element of y is mapped to by some element of x. Basically, all the values of y should be mapped to a value of x. There shouldn't be any value of y that is left out. In this example here, this graph is also onto because all the values of y are used. 1 is used, 2, 3, so on and so forth. It extends infinitely going upward, but we can say that there's no limit on which it extends. It also goes down infinitely, and it extends both to the left and to the right. This graph, however, is not onto because if we observe the graph, it goes down until it reaches the point 3. From here, it goes up. There's nowhere in the graph that will make it reach the value of y equals 2, 1, 0, so on and so forth. So in this graph, the points 2, 1, 0, so on and so forth are not used, and therefore they are not mapped, which means that this graph here is not onto. However, this first graph that we have here is onto. Now, the third classification is bijective. We can say that a function is bijective. It is both one-to-one and onto. Now, let's check if this function is a one-to-one function and an onto function. So we have f of x is equal to 2x plus 1. Now, aside from graphing, we can identify whether a function is one-to-one algebraically. So, what we're going to do is we're going to prove that if f of x sub 1 is equal to f of x sub 2, then x sub 1 is equal to x sub 2. This is what we want to show. What does this mean? This means that if there are two identical functions, then their source, the x's, should be the same as well. So what are we going to do here? We're going to take this function. So f of x sub 1 is equal to f of x sub 2. We're going to take 2x plus 1 but replace x with x sub 1. Then what we want to show at the end is this one. We should be able to arrive here. So we have 2x sub 1 plus 1 is equal to 2x sub 2 plus 1. So let's solve. We can subtract both sides by 1. So we have 2x sub 1 is equal to 2x sub 2. And then we can divide both sides by 2. Therefore, we get x sub 1 is equal to x sub 2. Since we're able to arrive here, then we've proven that this f of x is equal to 2x plus 1 is a one-to-one function. Now, let's prove if this function is onto or not. Now, the best way to prove whether a function is onto or not is by graphing it. So, if we can observe here, the graph of f of x is equal to 2x plus 1 is this one. It is a linear function. Now, for a linear function, all the x's has been used up. And for every value of x, there corresponds a value of y. Take note that this graph extends infinitely to the left and to the right. So we can safely say here that all the values of y's are used here. Basically, when we identify whether a function is onto or not, what we do is we try to identify what could not be the possible values of y. So if there's only one value of y that it cannot be a value on the function, then it's not onto. But in this case, all the values of y can be used, therefore it is an onto. Since the function is both one-to-one and onto, we can say that f of x equals 2x plus 1 is bijective. Next, let's try f of x is equal to x squared. So let's try to show whether it is one-to-one or onto. So we're going to do the same thing as what we did earlier. So we have f of x sub 1 is equal to f of x sub 2. Then we should be able to show here at the end is x sub 1 is equal to x sub 2. Therefore, we'll have x sub 1 squared is equal to x sub 2 squared. Since we have exponents of 2 here, what we're going to do is we're going to get the square root on both sides. Remember that whenever we get the squares on both sides, we use both positive and negative. Therefore, what we're going to have is positive negative x sub 1 is equal to positive negative x sub 2. Now, we're not able to come up with x sub 1 is equal to x sub 2 because this can imply that positive x sub 1 is equal to negative x sub 2 and vice versa. Thus, we did not arrive with x sub 1 is equal to x sub 2. This means that f of x equals x squared is not a one-to-one function. Now, let's see if this function is onto or not. So, we have here the graph of f of x equals x squared. Now, as we can see here, the value of the function goes down and down and down until it reaches 0. Once it reaches 0, it goes up and up and up. So there's no point in the graph where it reached negative 1, negative 2, negative 3, so on and so forth. Therefore, there are some values of y which are not mapped on this f of x equals x squared. Thus, this means that f of x equals x squared is not an onto function. So that's everything about classifications of functions as one-to-one or onto. So I hope you learned a lot today and thank you guys for watching.